Solid geometry is a geometry that has three-dimensional figure such as rectangular prism. A rectangular prism is a solid object which has 6 faces that are rectangles. It is a prism because it has the same cross-section along the length. In Theorem 1, it is stated that two intersecting planes meet in a straight line. So, if I will cross the planes, what will be produced? So, let's investigate. So, I have two planes here. The plane K and the plane I. If I will intersect these two planes, they can produce a straight line. And in this straight line, there are 2 points. The point P and the point Q. And we also know that a plane should meet at least 2 or more points because it is stated in axiom 3 that 2 distinct planes cannot meet in only 1 point. So, it means that this line PQ is the intersection line of the plane I and K. If a line PQ is the intersection, then the line PQ lies in both plane K and because it is stated in axiom 1 that if 2 points of a straight line lie in the plane, then the whole lines in the plane. So, therefore I conclude that the 2 planes intersect or meet in a straight line. A line and a point. This line A and this point creates a plane because of 3 non-collinear points, the point A, the point B, and the point C. We can call this plane as plane M. Next, a plane is determined by 2 intersecting lines. These 2 lines intersect. So, the line 1 and the line 2. The line 1 and the line 2 intersect by the point C. So, these 3 non-collinear points, A, B, and C, they intersect and create a plane. Next is 2 parallel lines. These 2 lines are parallel because they don't meet each other. And this line 1 and line 2. Line 1 contains point A and B and line 2 contains point C. There are collinear points in this plane. And we can call this the plane L. In Theorem 3, it is stated that if a line is perpendicular of 2 intersecting straight lines at their point of intersection, it is also perpendicular to the plane in which they lie. So I have a plane here. Given line AB, which is perpendicular to line BC, and also line BD. And this plane is called the plane MN, passing through the line BC. Through point B, draw a line BC. So this is the line BC of any other line in the plane MN. Draw any convenient line CD. So this is line CD. Intersecting the line BC, line BG, and line BD in the points of C, G, and D, respectively. Produce the line AB to AF. So here, assuming that this is the point A, it is connected to point C, point G, point D. So, making line BF is equals to line AB. Connect the points C, G, and D with A. So, assuming that. And also with F. So, therefore, I conclude that B, G are each equidistant from point A and F. Through a point, there is one and only one plane perpendicular to a line. So, through this point, there is only one plane perpendicular to a line. So, because we can call this point as point P and plane N. Point P, draw lines PQ and PQ1, and this both perpendicular to this line. Therefore, through this point, there is only one and only one plane perpendicular to this line. Theorem 5. Through a point, there is one and only one line perpendicular to a plane. I have a plane here, the plane P, and a point Q that lying on the same plane. 3 straight lines. So let this straight line perpendicular to a plane and these two remaining straight line intersect at point Q. So we already have a line here, the line 1, the line 2, and the line QS. So assuming that we have a plane I that passes through point Q and line 1. So this is the plane I. And let plane I be the plane which is perpendicular to line 1 at point Q. And let line QS be a line in a plane P that it is perpendicular to line 2. Then the line QS is perpendicular to line 1 because it is stated in Theorem 71 that a line is said to be perpendicular to a plane if it is perpendicular to every line in the plane passing through its foot. And therefore, I conclude that line QS is perpendicular to line P. And it is stated in Theorem 76 that if a line is perpendicular to each of two lines at their point of intersection, and it is perpendicular to the plane of these lines. This would be our point, and we can call this at point C. And this is the point A and the point B. Therefore, there is a line here, which this line, assuming that the line here is this line, and this line here intersects this point C. This is the point C. Then, this line here, or the point here,
is we can call this point P, and this P to this C is perpendicular to this plane M, because according to theorem 2 that there is only one point or through a point a line is perpendicular to a plane, so therefore they are perpendicular. So this AC and this BC are equal, so AC is equals to AB. So therefore this triangle P and CA, this portion here, triangle PCA, is equal to this portion here, triangle.
Thank you for watching. God bless.